Alright, so for this video, I'm going to be solving the equation x to the power of 4 is equal to negative 9. So what I'm first going to do is add 9 on both sides. So then these two cancel out, and I get x to the power of 4 plus 9 is equal to 0. Now from here, I can rewrite x to the power of 4 as x squared to the power of 2, and I can rewrite 9 as 3 squared. And if I have something in the form a plus b squared, this is equal to a squared plus b squared plus 2ab. And if I have something in the form a squared plus b squared, then this must mean that this is going to equal a plus b squared minus 2ab, because this is the same thing as this without the 2ab. So this means that a is equal to x squared and b is 3. Going back over here, so I get x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared. And this turns into x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared minus 2 times x squared times 3 is equal to 0. So now from here, I get x squared plus 3 squared minus 6x squared is equal to 0. And remember how the square root of 6 squared is equal to 6. So what I'm going to do is I'm going to rewrite this as x squared plus 3 squared minus the square root of 6x squared is equal to 0. And the reason I did that is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, this turns into x squared plus 3 plus the square root of 6x times x squared plus 3 minus the square root of 6x is equal to 0. So this gives me two equations. I have x squared plus 3 plus the square root of 6x is equal to 0, and x squared plus 3 minus the square root of 6x equals 0. So for both of these, because both of these are quadratic equations, you can use the quadratic formula to solve them. So by using the quadratic formula, I'm actually not going to do that in the video, but you can try that yourself. You should get that x is equal to the square root of 6 times negative 1 plus I over 2, and x is also equal to the square root of 6 times negative 1 minus I over 2. And also, along with this, you should get x is equal to the square root of 6 times I plus 1 over 2, and x is equal to the square root of 6 times times 1 minus I over 2. So these are your four solutions. Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and a to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem.